G'day guys, how's it going? So in this video, we're going to look at understanding references and borrowing in Rust. Now, primarily, how does it work? All right. Well, if we look at a program, we have a program like this called main, where we're allocating a string called hello world to a variable called a, which looks like this in terms of stack and heap memory. And then we go and we call this method called print message, where we pass in a. And then if you look at print message, we're just expecting a string, right? Now, previously we understood this to be a move, right? Because now we're saying swap the owner from A to S, right? And then inside of S, we can see that there's no return. So because there's no return, S is still the owner of the string hello world. When S is when the scope for print message ends, S is destroyed. So is hello world on the heap. And then we come back to main, to which A is not pointing to anything anymore because it's not the owner of hello world. And then that line on print line A is going to break. In fact, the compiler will even tell us straight away that we can't do this, right? And the way we got around this in the last video is we cloned the value of A before passing it into the function. But then what that meant was we had to duplicate the data on the heap just to get around the idea that we wanted to pass that value to a function, right? So there I said, is there a way to get around it? And then I said, yes, there is. This is the video where we're going to learn that. So what we do, technically, right, is say beforehand we're referring to S pointing directly to that piece of heap. If we want to get around that problem, we can use a little at symbol on the function, right? For print message. And what this now tells Rust is this function is expecting a reference to a string, not necessarily an ownership, right? And this is where the word borrow comes in the picture. What we're saying here is I just want to borrow a string. I don't want to own the string, right? So with that said, when we come back to print message in main, we also need to say, okay, I'm going to send you a reference to A now that you can borrow. And in that given situation, what ends up happening is we are now pointing to A. Okay. And now the reference can point to A can point to the heap memory, and that's how we get access to that value in the heap. Now, the result of this is a good thing. We now can do what we need to do inside a print message. We can print that message out just by accessing it like we'd access a normal string. And then when we return from print message and we're back on the last line of main, we still have ownership of that string hello world left with A. So A is still the owner. So in this situation, the function is going to be okay and the code will actually compile and run. Hopefully that makes sense. If it doesn't, well, we're about to step into the code and see a few more examples. Okay, so now I'm in the code, and essentially I've written a program very similar to what we just saw on the slides. The only thing I've included is a let b equals 1, and that's just so I can add a breakpoint in the code to illustrate you what happens to A when we pass it a reference versus when we don't, right? And I've also commented out in line 11 because obviously based on the current program, if I leave this in, it's going to let me know that I can't do anything because I've moved it, right? So at the moment, this code is doing a move, right? So let's just quickly run this program and show you what A looks like at every phase of the program. So I'm going to be debugging the start where we first get in the main, then we'll run to the inside of print string, what A looks like in there, or what A is on the outside from there. And then ultimately we'll find out what A is when we hit line 12, okay? And then we'll show the difference when we add a reference. So let's just debug this program. And we're going to hit line 6. Now at the moment, there's no local variables over here. So I'm just going to step to the next line. And now you can see A has been initialized to hello, right, which is this text here. Now, when I come and I just run so it goes into line 2, which is the body of print string, it's going to show S here with the value of hello, right? Now, if I go back up into main, so this is the call stack, that's there for any Rust application. But I can see this one borrowing main. If I come up to here, it still says hello for now, right? However, if I allow the code to leave this method and come back out, now you're going to see that A is pointing to some gobbledygook, right? And this indicates that we're no longer pointing to anything because we're doing a move, right? So this no longer is pointing to the heap memory that says hello. That's the point of that, right? And that's the case for the rest of the program as well. So you can see on line 12, same deal. And then the program will execute line 12 and exit, and it just shows B is equal to 1, right? Cool. Now, let's change the program up, and now let's refer to references and borrowing references instead. So now we're going to borrow the A as a reference, and we're going to print it out in print string, right? So what this will do is A should be the owner even when we come out of the print string function, right? So let's debug the same program in the same manner. And again, we're initializing on line 6. We get to the next line. We can see A is hello like it was before. Then ultimately, we go into print string and we come up into our call stack. We can still see it says A is equals to hello. But when we come out of print string, so I'm going to step out of there, come back to this line, you can still see A says hello, right? Because A is still the owner of that text hello. In this case, print string is taking its borrowed string, it's printed out the value down here, right? And then the borrowed string pointer is destroyed, but because it's just a pointer, the pointer gets destroyed, not the value. That's the important distinction here, right? So A is still alive, it's still sitting on the heap until it gets to a point where main ends, right? So it's still available even on line 12. We can still see A is there, and then the program, when it ends, finally, you can see everything's destroyed off the stack, and therefore this value would be destroyed off the heap as well. And then that's the end of the program, right? And just to demonstrate that it actually will allow us to still print out the value of A afterwards, I'm not going to debug it this time. I'm just going to get rid of the breakpoints and just run it. And essentially, there we go. Value inside print string is hello. So we've been able to borrow A, print this line out. Then straight after that, we'll be able to print A is hello and B is 1. Cool. So that's a really simple example of references and how we can borrow a reference from the original owner. In the next video, we'll look at some caveats to doing this as well as some exceptions to some of the things you can run into when doing this. But I don't want to do it now because this video is long enough. So I will see you all in the very next video.